Hello! Today we're going to look at solving a quadratic inequality, and I'll show you first of all a common mistake in the way of solving it, and then I'll show you what I think is the best way of solving it. So generally when we see a quadratic we think factorize. So that's great. So factorize, what do we get? X and x. Two numbers multiply to give 5, add to give -6. -1, -5, and it's less than 0. So the common mistake is to then take each bracket to be less than 0, and we end up getting x is less than 1 and x is less than 5. So let's test out and see if it works. So x less than 1, let's try 0. 0 squared is 0, subtract 6 times 0 is 0, plus 5. Well, that's 5. So 5 is less than 0, doesn't work. X less than 5, let's test that out for 4. 16, 4 squared is 16, subtract 24, that's -8, add 5, -3. -3 less than 0, that does work. It does work, and it works until you get less than 1. So somehow this has gone wrong and doesn't work. So what we do from this stage, I would suggest, is that we're going to sketch it out. So as soon as you've factorized, you know the main features of the graph, therefore you can use the graph to help you. So let me start that again. So there's my y-axis, my x-axis. And by factorizing, I know the roots. In other words, where this graph, y equals x squared minus 6x plus 5, is going to cut the x-axis. So one root is x equals 1. 1 subtract 1 is 0. So 1, and the other root, x minus 5 equals 0. So x equals 5. So there's both roots. It's a positive x squared. Therefore it's a U-shaped graph or smiley shaped graph, positive x squared, smiley shaped. So your graph of y equals x squared minus 6x plus 5 is going to look something like that, sketch like that. Now where is it less than 0? So where is y less than 0? Well, it's this area here below the x-axis. I should start that again. Right, I'm trying to find a different color. Let me get a different color, that's probably better. Right, so here we go, the area below, or the part of the graph below the y-axis. That's the bit that's less than 0. So what values of x does that apply for? Well, that applies for x between 1 and 5. So let's test that out. Let's try 3, for instance. 3 squared, 9, subtract 6 times 3, subtract 18. So -9, add 5, -4. -4 less than 0, yes. So I would suggest whenever you see a quadratic inequality, you factorize to find the main features of the graph, and then you sketch it out. And whether it's greater than 0 or less than 0 depends on where you, or which part of the graph you actually look at. There are other ways of doing this, but that's the way certainly I prefer. Goodbye, and thanks for watching.